Good afternoon. Welcome to another Research in Action brought to you by the Division of Research at Florida Atlantic University. We're very happy to be here, to have you here. Before we get started, a few logistics. We would like to answer as many of your questions as we can during our time, but we will not allow audio questions due to the number of attendees typically logging in. So if you hover your mouse in the bottom of your screen, there is a Q&A button. If you click on that button, you can type your question. You can type your question at any time during the presentation. We will go through those questions after the presentation has finished, but please feel free to pose your questions there at any time. With that, it is my great pleasure to introduce to you today's speaker. Dr. Shermeen Yousif is an assistant professor of architecture at Florida Atlantic University and received her Ph.D. at Texas A&M University. Her research is situated between performance-based computational design methods, big data, and machine learning. With that, I'm going to turn it over to Dr. Yousif.
Good afternoon, everyone. I hope that you can see me all right now. So thank you, Karen, for introducing me. I'm going to start sharing my screen and start the seminar. Okay. I hope everything is good. Okay.
Looks good, Shermeen.
Yes, perfect. Thank you. So yes, I'm Shermeen Yousif. I'm an assistant professor at the School of Architecture at Florida Atlantic University. And today I want to present on this interesting topic that I have been researching recently, artificial intelligence. So the title, the role of artificial intelligence in augmenting our architectural design is a big title. It's a huge topic in general, but in the lecture, I'm more concerned about AI creativity and interested in AI creativity in relation to architecture design process. Another important aspect about artificial intelligence is, which I believe in, is the neural science behind it and how AI creativity can tell us about our own creativity as humans. And both are really complex ideas and research kind of disciplines beyond my research, but it's really interesting how we can think of AI that is a reflection of our own creativity and the way we think and how AI agents and algorithms think and so on. It is important, I think, in this topic to find our definite goals and what are our objectives using AI applications. So how we understand intelligence and how we build intelligence. My presentation is divided into these topics of starting simply with introduction to AI, and then AI strategies, AI and architecture, because just to let you know, my background is architecture, and I've done research in computational design, but only recently I've been involved into AI. So I can't say that I'm an AI expert, and I'm sure computer scientists have a totally different kind of perspective to the topic. So my perspective is from the architectural point of view. And I'm interested in solving or potentially suggesting solutions to current and future issues in architecture, and then how AI can help potentially in augmenting architectural design process and augmenting and automating my area of research, which is building performance simulation and optimization. So I hope that you will enjoy the presentation. And starting with introduction to AI, I will actually start with this simple video, and then we'll talk about it in a second.
Do you know what the Turing Test is?
Yeah, I know what the Turing Test is. It's when a human interacts with a computer And if the human doesn't know they're interacting with a computer, the test is passed.
And what does a pass tell us?
That the computer has artificial intelligence. Are you building an AI?
I've already built one. And over the next few days, you're going to be the human component in the Turing test.
Holy shit.
Yeah, that's right, Caleb. You got it. Because if that test is passed, you are dead center of the greatest scientific event in the history of man.
Yes, I'm going to stop here. And I hope that some of the audience have enjoyed watching the movie. I started with this clip of the movie Ex Machina because it defines or it explains very briefly the Turing test. And I believe that this Turing test is can be considered one of the turning points. We can trace back AI to the beginning of computers, right, in the 50s. And to define artificial intelligence, there's many definitions. And then one of the straightforward ones is that it's also called machine intelligence, which is intelligence demonstrated by machines, and it's artificial. So it's unlike natural intelligence that we display as humans or animals. And the leading textbooks define AI as the field of studying intelligent agents. And any device that perceives its environment and takes actions that maximize its chance successfully achieving its goals. So one of the important concepts of AI is this Turing test that is explained in this scene. And this movie is really interesting because it tells us that in the beginning, we see that Caleb, the main character, is actually thinking that he is being used to test the AI. But then later in the movie, we see that Caleb was on the test because the AI, the robot, was really intelligent. And yeah, very interesting movie. And moving forward in the presentation, I'm trying to give you all some important events that happened that redefine AI. Back in 1996, there was a moment on February 10th when a computer was actually defeating the chess world champion. And then this moment becomes a turning point because it kind of brought the development of AI to the public. And Deep Blue, which is a chess playing computer developed by IBM, had really defeated the world chess champion. And at that time, there was less development, or AI was different. So there was brute force and other algorithmic methods and tools. But more recently, we see AI has been really progressing, and one of the turning points, again, in the recent history is the time that a computer was actually defeating the world champion in Go game. And there was this event, and there is a documentary on that, AlphaGo versus Lee Sedol, which is known as, the event overall is known as the Google DeepMind Challenge match. It was a 5-game Go match between 18-time world champion Lee Sedol and AlphaGo. And AlphaGo is a computer Go program developed by Google DeepMind and played in Seoul, South Korea between the 9th and the 15th of March 2016. AlphaGo won all but the 4th game and moved 37 in the 2nd game. And then other moves later have redefined our perception of AI because they were really, really creative moves. And then one of the very famous quotations by Lee Sedol is that in the 2nd game, when he was defeated, he said, "Yesterday I was surprised, but today I'm speechless." So Lee Sedol did not expect certain moves. And then for us, for me in particular as an architect, I think this AI creativity is really, really interesting and important because there's unexpected decisions that AI can take that we have never think of or thought of previously, which I think becomes really interesting. Now, more recently also, within the same 2015, 2016, this development of deep fake. And deep fake, I assume our audience knows about, but this video shows us great potentials of AI when we have...
I'm Jim Eskerman, and I wrote a poem about what it feels like to be an
impressionist. And I'm going to stay silent because it's a very interesting video.
Is anything more sad and lame, contemptible, beneath disdain, in short, provoking of disgust, than being an impressionist? A third-rate, even fourth-rate skill. The definition of cheap thrill. Like watching farm equipment rust.
Oh, I'm sorry. I apologize. Something went wrong. Yes. I'm going to skip some part.
Disdain, in short, provoking of disgust, than being an impressionist. A third-rate, even fourth-rate skill. The definition of cheap thrill. Like watching farm equipment rust is watching an impressionist. Relic from a distant day that long since should have died away. Dishonorably mentioned is the pitiful impressionist.
Weird and slightly ostentatious, tired debris from old Las Vegas,
whose former fans have long dismissed allegiance to impressionists.
How many opportunities passed up and wasted because he's
hell-bound to follow what he must? Pity the poor impressionist.
doomed to live in an abject failure, dogged by his own echolalia? Better to crumble into dust than wind up an impressionist. His borrowed voices can't deflect a life of well-deserved neglect.
His name's on simply no one's lips. Forgotten, vain impressionist. That sound, did anybody moan? That creature with the microphone
is last on everybody's list. Forgettable impressionist.
When Peter, at that shiny gate, condemns those souls who imitate.
You will but shake a heavenly fist and curse condemned impressionists.
But till that time, we'll tolerate the good-for-nothing reprobate.
And hide the truth that we're just pissed that we can't be impressionists. Huh.
Yes.
But we and
so I'm gonna skip this because I want to explain AI strategies and then refer back to this video. So I was interested in deep learning in my research, but to give you an overview, where is deep learning, and when we say machine learning, AI, deep learning, how do we actually categorize and kind of define those terms? So that's, to keep it simple, AI, artificial intelligence, is the big umbrella. And within AI, there is machine learning strategies such as regression, linear regression, logistic regression. And then within machine learning, there is this representational learning or representation learning. And then within that falls this area of deep learning in the kind of smallest circle in deep blue. Now, or in darker blue, sorry. So basically, deep learning can be considered the most recent turning point that has brought this progress to artificial intelligence and applications to many disciplines and fields. And deep learning, this class of machine learning, is really complex, yet it's capable of doing multiple things that other previous strategies were not capable of doing. So there's this multi-layered or stacks of layers that can process levels of representations and from unstructured data and so on. So unstructured or structured. So there is deep learning, supervised and unsupervised layers. So I want to talk about one important aspect within this topic is there is the author Ian Goodfellow. Ian Goodfellow, which is the author of the book Deep Learning. And I'm really interested in his view, which is what he says is that in the early days of artificial intelligence, the field rapidly tackled and solved problems that are intellectually difficult for human beings, but relatively straightforward for computers. Problems that can be described by a list of formal mathematical rules. The true challenge to artificial intelligence proved to be solving the tasks that are easy for people to perform, but hard for people to describe formally. Problems that we solve intuitively, that feel automatic, like recognizing spoken words or faces or images. So this area of computer vision and image recognitions and so on has been really becoming an area of research and a very interesting topic. And as Ian Goodfellow is saying, is that it's the tasks that for humans are intuitive and really easy are really difficult for computers to perform, like vision, right? So this has brought the development to AI, and then within this kind of progress, we can trace the actual change and development of AI from 2014 to 2018 with those synthetic images. So these are images of humans that never existed. So they're synthetic or fake. And synthetic is a more accurate term to describe them. So this has been within the book that I'm also interested in, which is a book by David Foster. And David Foster defines generative models as those models that kind of process data sets and generate new data sets. So in terms of probabilistic models, they sample and they're able to generate new data. So feeding the neural network hundreds and thousands of images, it can actually, the network and the AI agent can synthesize new images or faces that are really realistic, but they're synthetic, right? So they're really images of people that never existed before. So that has been kind of progressing, and to simplify the actual concept or the technical concept of AI, there is this important method that is called generative adversarial networks that I'm interested in, and GANs for short are this kind of like represented here in this diagram, this kind of architecture where you have a generator and a discriminator. And there is this somehow a competition between these two neural networks, the generator and the discriminator. And there's always this bottom-up generator, and let's call it an artist. And that generates images, and those images are non-real. We can call them fake or synthetic. And then there is the critic. The critic is the discriminator. And then that critic can evaluate those images. And then in the competition, the generator attempts to fool the discriminator by producing images that are as realistic as possible. And then the discriminator that is supposed to be unable to distinguish. So the generator's role is that to somehow deceive the discriminator. And then effectively, GANs is working in the training process is that both are being trained. So the generator becomes better at producing synthetic images, while the discriminator is also getting better and learning how to detect real from fake. So both of them are learning in this learning process that's called machine learning, or in this case, deep learning, right? So there's multiple layers happen in between. And interestingly is that the two, discriminator and generator, work in this tandem, and then the artist trains the critic, and the critic trains the artist, right? So more methods within this GANs architecture that I'm personally using. There's this simpler version, which is on the left side, the pix-to-pix, which is a more supervised, and it takes paired sets of data. And there's only two networks, the generator and the discriminator. So it's a simpler version, while on the right side, you see a diagram of the complex GAN architecture. And in this case, it's called cycle GAN. And in cycle GAN, there is 8 networks. So basically the networks within the GANs here compete, and then trying to generate a synthetic, but yet as realistic as possible, while discriminators are actually performing this kind of correct classification, identifying which ones are synthetic and versus the real ones. So it's a more complex architecture on the right side. Now, in architecture, AI has been really an kind of infant research area, let's call it this way. Only in the 5 years, AI has been applied to architectural design problems. And one of the very interesting applications is this actual work and the work of Stanislas, as you can see on the left side. So yeah, what Stanislas, and he's an architect, worked on is this particular pix-to-pix GAN that I showed you earlier. And his focus in this part of his research is to automate the generation of interior partitions and floor plan design. So the network takes input of footprint, building footprint, giving this kind of housing unit, and the position of its entrance door, which is in the green square, and then the position of the main windows specified by the designer. And then the plans used to train the network derive from database of, he used more than 800 floor plans, and then probably annotated and given in pairs to the model during the training. And then the output, as you can see here on the right side, the output. So on the left side, this is the training and what's happening. On the right side, you can see that what's happening is actually the program learns how to generate these floor plans within the footprint of the building automatically, and in a very smart and intelligent way, because it learned throughout the process. So the color coding represents spaces within the building, within the housing unit. And then there's also some structural elements you can see in the black hatching that represents walls and partitions in between. So this is one application. One of the other interesting applications have been done by Professor Daniel Bolojan, my colleague at School of Architecture, FAU, and another professor, Professor Vermiso, Emmanuel Vermiso, and they both presented or gave a workshop last year in 2019 in the fall as part of an important computational design conference called ECAD. And in their work, in the workshop, they actually have done something really interesting, which is they call it Gaudi's hallucinations. And hallucinations are really kind of, as a term, it has been used kind of rapidly when it comes to AI and the output of AI. So AI here is being used, in this case, CycleGAN, to kind of map or translate domains. And the two domains, the two data sets were an important iconic building, Sagrada Familia, designed by Gaudi, an important architect, Antoni Gaudi. And then the other data set was a forest. And then the AI learned how to map the semantic features of the building of Sagrada Familia and kind of translated into a forest-like structure and so on. And here I think the beauty of AI is that we think of it as less smart or less intelligent, but here it shows some intelligence and some kind of levels of semantic translation, where it really knows how to kind of map and translate certain architectural features and elements, creating those spaces and spatial qualities that are sometimes really complex for designers or architects to think of. And we believe, so we have now a team at FAU School of Architecture, including myself, who are interested in this AI creativity that can open potentials to designing buildings that we've never actually conceived or even thought of. And that's, I think, the beauty or the applications of AI or the potentials. Now moving to another example, more pragmatic and industrial, which is a startup company called X-Cool, developed or led by architect Wen Yu-hee. And Wen Yu-hee here has actually established this kind of interesting approach. And in 2017, they launched what they called Rosetta Project, which is creating Rosetta Stone in the field of architecture. And the idea is to build a large database of design styles, logics, and ideas by studying a large number of existing exceptional architectural cases and to output more valuable intelligent design results to inform human designers. Now, on the left side, the many images, or let's call it in the middle, represents actual buildings, but on the right side, the 3 buildings on the right side are actually synthetic. Okay, so they're produced by AI. They're not produced by an architect. So that's a very interesting application. Now, what are the problems that AI can actually solve in addition to design creativity, and how AI creativity can apply it on multiple levels and multiple building systems is my interest and my research focus. So basically, in my PhD, I studied building performance simulation and optimization. And we now, and in the very near future, have very many challenges that I believe AI can really automate and augment the problem-solving process for those challenges. So for example, by 2060, the world is projected to add 230 billion square meters of buildings, or an area equal to the entire current global building stock. So we're doubling the building stock. We're building the double of what we've been building since early kind of times of humanity, which is the equivalent of adding an entire New York City to the planet every 34 days for the next 40 years. So this is an alarming number and statistics. So basically, how do we respond to that? So we believe that this problem should be solved by, just like any environmental challenge and problem, we need to solve it with new ideas and new methods and new solutions. This population growth and the urban development needs to be solved with different methods. So the world is really undergoing a large wave of urban growth. And then more than half of the population is now concentrated in urban areas. And then by 2060, 2/3 of the expected population of 10 billion will live in cities. So these challenges that we are predicting would actually require us to do better in terms of the building design process and architecture design. So what we believe, what I believe as an architect is that we have to, we don't have actually the luxury of wasting resources and materials and energy resources. So we have to be really careful. And this concept of building performance simulation and optimization become, I believe, the only scientific way. So how do we analyze the building performance before it's being built? And this integration of building performance simulation early in the design process becomes a very important research area and aspect. And this graph here that you can see on the screen represents what we call the 2030 architecture challenge. I remember this graph 5 years ago, and it was supposed to be by 2020. We should have carbon neutral buildings, but we didn't achieve it, obviously. So we had to defer it to 2030. So we're hoping, and many firms and architectural practices are actually subscribing and trying to meet this challenge, which means that the motivation is there from designers' perspective and architects. We want to build energy efficient buildings. We want to build and design net zero buildings and carbon neutral buildings. We have the intentions, but we need to learn and use the advanced technologies and strategies. And I believe, and this is my humble opinion, AI can really facilitate achieving those goals. There's one interesting practice that I'm kind of excited to present about, which is called a space maker, which is an AI-based startup. And then it is basically taking AI to the level of urban scale and analyzing cities and as you can see here, AI is being used to actually detect and evaluate multiple urban scenarios and cases. And how can we use AI to get automatic and instant feedback? And you can see also potentials of solar, potentials of so mapping and certain layers of information, and how it can actually help us. And then detecting and simulating multiple design cases, all facilitated by AI methods. In my current or very recent research, I've been investigating potentials of AI for augmenting building performance simulation. And what that means is that this is a very recent paper submission that I submitted. I've been working with Professor Daniel Bolohan on, which is using AI for automating building performance simulation. And what that means is that on the left side of this diagram, you can see that usually as designers right now, as architects, we come up with what we call generative system, which is we create multiple hundreds and thousands of building models that are represented by parameters and constraints, and that system is smart so that it generates multiple design alternatives, and then evaluation process happens usually aesthetically and performance driven. And in terms of performance, we usually use environmental performance, for example, the energy footprint of this building and the daylight simulation of the building. And in this case, daylight, which is an important aspect because incorporating successful daylight design in the building will actually achieve reduction in energy consumption for artificial lighting. So that's the perfect case. We want to minimize artificial lighting in the daytime. But then on the other hand, we don't want heat gain. So we have to simulate certain shading devices and smart building skins and envelopes, responsive and so on. Now we are using AI, in this case, Pix2Pix, so that we take all of the floor plans that the system, computational system generates for us, and then we train an AI so that it takes the floor plans and then it can predict the daylight simulation represented in these color-coded meshes, blue, between blue and dark blue. And then basically, we're creating a system that for lay architects and designers with no background in simulation and optimization can use it directly as the model or system that can automate for them the performance evaluation process. So they don't need the simulation, which takes sometimes hours and days. And it's not only that, they don't need the expertise and the knowledge. They can plug in the trained neural network, and then they have their own design system, which is the parametric model that can generate multiple alternatives. And then the AI will give them the prediction. So the AI works in this case really successfully. So what we did is that we tested what we call real versus synthetic image. So on the left side here, you see paired data, and those paired images, one of them is the real image on the right side of each pair. And then the left side is synthetic, which means that it was the image predicted by the AI after the training. And we trained the AI in this case for 3,000 images multiplied by 5. So in fact, it's actually 15,000, and it successfully predicted for us. It's a very high or highly accurate. So we used a system called SSIM, which is the structure similarity index measure, which is a metric that can actually detect any variations between two images. And in this case, it gave us values minimum 91%, which means 91% is actually similar, those two images. And this gives us this kind of potential, or offers the potential of using AI to automate tasks and predict accurately. Those tasks that can be either not interesting for designers or not the main focus for designers. So as architects, we want to retrieve building performance analysis, but we're not energy modelers necessarily. So we want to have this automatic and instant, and this AI can do this for us. So that is our research objective here. Now, more recently, we actually have this, we have a conference, digitalfutures.world, architectural conference on computation and digital design. And then FAU participated, and the three of us, Professor Daniel Bolohan and Professor Emmanuel Vermisso and myself, gave the workshop. And the workshop, we call it Creative AI Ecologies, Augmenting Architectural Agency. So I want to briefly describe what is our agenda or manifesto to this workshop. So for our manifesto, or how we actually wrote the description of the workshop, we said that in light of the observed integration of artificial intelligence within many industries, this workshop reconsiders architectural design cycle, proposing nested generative AI design processes. The workshop will deploy AI creativity to tackle a variety of architecture systems, including formal articulation, structural logic, and enclosure responsiveness, combining parametric and AI layers by means of domain transfer and representation learning. Two parallel iterative workflows will address design at different scales. So we were very ambitious, and we developed this diagram, and we divided our workshop participants into 24 and 6 groups. And so each group will have 4 participants, and the 6 groups, one group will be on the left side, you can see it's urban level. So 3 groups are urban level, and then the other right side is another 3 groups. So we wanted to actually kind of approach AI at multiple levels and at multiple building layers or building design process. And building design process is a very complex activity and task. And that's why we believe AI should be used to tackle complexity and facilitate complexity. And basically what has been done so far, this is our understanding or agenda, is that we use AI for one certain aspect or in the design process, or maybe 2. And then our agenda here was to actually use it at multiple levels, multiple layers, and also use it as an urban scale and at architectural building scale. So I'm going to show you some results from the group's work and explain what each group did in a very brief way. And I'll go back to this later. This is the holistic, or maybe I'll show you now. So this is the holistic video of all the groups' work. And this is within the urban scale. We're still in, this is group 2 right now, which is called encoding, translating. And then group 3, synthesizing, and they did analysis of cities, solar analysis, shadow analysis. So on the left side, you saw video, and the right side is the analysis by AI. And then this is group 4, tackling floor plan. This is group 5 and 6. And this is group 6, basically tackling the issue of responsive skins and how solar radiation can inform perforation in the building skin. And then this is group 5, where they actually tackled somehow topology optimization and material distribution, and how AI can be used to actually automate this kind of a process of spatial features, topology optimization, and yes, and material distribution. Very interesting results. We were very excited, and since this is very short, I will just simply explain what each group did one by one. So basically with the group one, we can see that, okay, my apologies. With the group one, they actually focused on the concept of learning, and they used 4 all pix-to-pix networks to actually, with paired data, to start with the left side with just a sketch and a tractor curve, and that can inform reaction diffusion pattern, which is in this case gray-Scott pattern, and that in itself informs displace points that are like a heat map of surface curvature and certain kind of topology features, and then that can inform radiation analysis, this heat map in the middle, and then in itself can inform settlement strategy. So if this is a topology, an urban or not, so yeah, so an actual topology, how do we distribute certain settlement and residential units and so on? So that was a certain question they answered, which is settlement strategies and maybe roads, maybe infrastructure can be informed by those aspects and features. So very interesting result. Group 2 actually took another approach, which is how methods of translating encoding can be applied. So domain transfer to multiple networks, and then each network would have 2 data sets. And I'm presenting here only one network, which has 2 data sets, informal city and formal city, and how this kind of domain transfer can give us more kind of new designs to informal cities or formal cities. So we can actually think of both. So how do we actually reorganize and redesign certain informal settlements? Group 3, they actually did more research on in tackling synthesizing. How can we use AI, cycle again, and they also use pix-to-pix networks to somehow map and use AI to detect and automate this mapping and site analysis process and distribution kind of, and you can see here images that sometimes bird's view and sometimes top view, and urban data and urban layers. For example, they had this results, qualitative qualitative results presented using GANs architecture, so that AI kind of automated the city footprint analysis, the height, gradient, shadow analysis, and solar analysis, like you can see here. Group 4, which is very interesting kind of approach, they actually moved to the architecture level. So here you can see that, yeah, my apology. Yeah, so group 4, they actually took the site, and at this site level, how we use AI to automate this footprint generation, and then from footprint and interior layout generation, how we inform mass articulation and organizational methods for the actual building. For example, here you can see on the right side this interior layout and certain axialities and certain spatial kind of masses can inform a more slightly geometry. At this point, it's not defined geometry, but it can be the beginning of a certain kind of mass design or mass modeling. Group 5, we're actually using certain aspects of morphology and tectonics. So basically, they actually mapped certain coral structures as inspiration for certain spatial features and semantic features. And they actually use pix-to-pix and in the end cycle GANs to basically inform or have AI give them results that are predicted and yet maybe unexpected kind of results of how the spatial configuration can emerge and how structural and tectonic features can actually emerge also in the process. And in the end, this is group 6. And as I told you before, they actually tackled more like the responsive skin and the facade of the building that in this case, it's very abstract. You can see only these surfaces, but this is a representation of like a building skin. We just had few days, and continuing this research, this can be mapped or kind of used as an enclosure, as a building enclosure system, which is a responsive skin that can be informed by solar radiation and perforation and certain texture qualities. Okay. One last thing I want to simply talk about is that we have an initiative at our School of Architecture, which is to establish an AI lab. And AI lab, I believe, is very important, not just for our School of Architecture, but at the Fort Lauderdale campus, because it's a very kind of strategic side. And we believe that this lab will provide this cutting edge technology for the school and for the local community engagement and research efforts to explore the use of technology as a driving force for design thinking, shaping and realization of architecture in the age of AI, deep neural networks, augmented reality, smart sensors and big data. And these key technologies are going to be used to develop complex simulation at varying scales, parameter or parametric design models and augmented reality models. This will allow us to have this real-time interaction between designers and users and the models. And then as the accuracy and speed of simulation increases, a wealth of building performance data will be available, intuitively posing dynamic trade-offs between alternative approaches. So by developing this lab, where we will be using machine learning, deep learning, AI optimization workflow, and creative AIs, interactive web interfaces, and augmented reality, all resulting in this framework and process-based lab that will provide a collaborative environment, providing real-time design performance feedback for students, designers, architects, and our local communities. And we're thinking that the impact of the lab will expand beyond just FAU and the immediate surrounding, but maybe for municipalities and kind of in the region of Southeast Florida. Thank you so much, and I welcome any question.
Thank you very much, Shermeen. As a reminder, if you have any questions, please hover your mouse in the bottom of your screen. There's a Q&A button. If you click that, the little pop-up comes up and you can type in your questions there. If you don't get to your question today, we will ask Dr. Yousif to answer those offline. And the answers, as always, will be listed and posted on our website together with a recording of this presentation. With that, I'm going to start with the question. So architecture often is related really to art, and often buildings are artful. Your Sagrada Familia that you showed earlier is really an art object, right? Or I would view it as such. AI is not known to having really creative minds. Is using AI in building design more to save time, to do repetitive tasks, or how do you combine those two ideas?
Yes, it's a great question. From my perspective and from my colleagues, we're really passionate about AI and we believe in AI creativity. The reason we believe in AI creativity is that I guess maybe this kind of question comes from what has been done recently, which is AI used in a supervised structure or supervised ways so that it's used for classification and correct kind of prediction and so on. But we're more interested in this generative deep learning or generative architecture. And in this case, what I mean by architecture is the networks. And the generative models usually, they don't necessarily kind of classify, or they don't do the supervised method. So what they do is that they generate unexpected results. So from my perspective is that AI is creative because it generates what we can't even think of, and opens possibilities for us. Unfortunately, as architects, we sometimes have either kind of limitations, or we think of certain ways, and even with computational design tools, which open also possibilities. I believe that we are also trained. So there's this analogy that as architects, we're also trained in education and in practice by kind of viewing and seeing many building designs, and then we actually come up with building designs that are related, or they're informed by what we've been seeing, right? But AI, using the computer power, is capable of handling thousands and thousands of kind of training data sets. And then I believe myself is that it can offer or it can give us more creativity in a way that it can generate what's unexpected. And I guess this goes back to the question in AlphaGo competition. I saw the documentary, and all the moves of the program was calculated, right? But then there was one move, and I think two moves, one of them 37, was really unexpected. And Lee Sedol, the world champion, thought that this was a mistake. But then AI had a more kind of strategic move that it looked like a mistake. So this moment represented AI creativity, is that AI can give us something that we don't even think of, or we think of as a mistake, but in the long run, AI won the game. So there was this unexpected. So I'm interested in this kind of unexpected outcome. And for design creativity, I believe AI is really possible of offering this kind of the unexpected.
Very interesting. Maybe the way our houses look is not really how they should be looking if we actually
yes, yes.
Yeah, so here in South Florida, we are facing a number of natural disasters, if you like, right? We are talking about sea level rise. We have a lot of hurricanes that we have to deal with. Is there any role for AI in designing a building that would provide solutions for the problems that we're expecting to face in the future?
Mm-hmm. Yes, that's a great question. And that's basically what I'm interested in addition to creativity, is that AI, I believe this Space Maker startup is a great example where they use AI to actually analyze urban scenarios. And I believe this approach is really important, especially in our area, Southeast Florida. So with AI methods, we can kind of simulate and automate that kind of simulation and expect or predicting future scenarios. And we know that the sea rise, the levels of sea rise, and everything happening, hurricane scenarios and displacement, and all of these issues. And now the pandemic, I believe AI has a great role in facilitating such analysis, evaluation, and predicting and kind of giving us or offering informed decisions that can help us with informed decisions, so that we actually tackle those design or future problems. So yes, I see this AI application as really kind of needed right now.
Thank you. We have time for about one more question. If we did not get to your question, don't worry, we will have Dr. Yousif answer the remaining questions online and then post them on our website. You mentioned earlier that the prediction is that there will be a tremendous growth in buildings. The question is, will old buildings be demolished to make room for that growth, or are we actually adding a large number of new buildings to the already existing ones?
Yeah, so the website, the architectural challenge is that it says that we will be adding, but we also expect that building life cycles are usually 50 years, right? So any older building will be kind of maybe remodeled, and also kind of there's adaptive reuse, maybe can be used differently, which is efficient because at least we have a structure that we can adapt. But what that prediction is in particular saying is that we are actually going to build new structures. So it's even more challenging. So, and then because of the population growth, we have this housing, we need to house those kind of new generations. And basically urban densification is expected, and sustainability wise, urban densification is actually a solution, but then right now, I think with the challenges, with the environmental challenges, then how do we actually approach this urban densification? So there's multiple problems and multiple environmental issues and challenges that we need to solve simultaneously. But the actual prediction is saying that we will build the double of what we've been building since the early kind of times. So it's a very, yeah.
That's almost scary. As a follow-up question, real quick, you've shown AI in the use of the design of buildings. Is the use of AI also translated into the use of machinery as you construct buildings?
That's a great question. In fact, there is this, what I like, the way I understand the question is that AI for robotics, maybe, and fabrication. So I believe now there's this AI and robotics, a huge research area, and it's somehow it's progressing really fast because there's a need for kind of preservation and kind of like using our materials in a very efficient ways, because we will run out of resources, right? And then robotics informed by AI intelligence, then it becomes really important. So I agree that the way we not just design buildings, the way we build our buildings should be also rethought and reconsidered.
Great, thank you very much. We're unfortunately out of time. Again, if we did not get to your question, we will address those offline and post on our website. With that, thank you very much, Shermeen, and look forward to seeing everybody again next week. Have a good day.
Thank you all. Thank you for this very interesting opportunity, and I'm honored to present today. Thank you so much.
Bye-bye.